Welcome to lecture number 2 on the course of electrical circuits and network analysis. In this lecture, I will discuss about different types of system, element and sources, right? So first of all, what is a system? A system is an entity which can take the input signal and produce the corresponding output signal. Okay. Basically, it is a combination or the interconnection of the different element, right? So, if we draw the block diagram of the system, so this is the lecture number 2. Okay. So, first I will discuss about system. So, if we draw a block diagram of a system, so this is a system. It takes the input signal, right? Suppose the input signal is x1 is a function of time x1 t. Suppose the second signal is x2 t. So and so on the xn t. Okay, it takes the input signal and produce the corresponding output. That means the output of the input signal x1 t will be y1 t and the corresponding x2 t will be y2 t and so on. The output of xn t will be yn t. So this is basically the system. Okay. So now different types of systems are there. So the first one, the number 1 is continuous time system and discrete time system. Discrete time system. So first of all, what is continuous time system? A continuous time system is that which accepts only the continuous time input signal and produce the corresponding continuous time output signal. Okay. On the other hand, the discrete time system means it transforms, but it converts the discrete time input signal to discrete time output signal. So that is basically the simple concept of continuous time system and discrete time system, nothing else. Okay. The second one is time invariant and time varying system. Time invariant and time varying system. So what is time invariant system? A system is said to be time invariant or it is a fixed system if the behavior and the characteristics of the system do not change with respect to the time. Okay. Otherwise, the system is called time varying. That means the system completely depends on the time. Its behavior is changeable with respect to time. So this is called the time varying system, right? Suppose if I give an example, suppose this is a system, so this is a plot. Suppose this is time axis, the x-axis, and this is your input, suppose xt. So this is the origin. So if we draw the input signal like this, the corresponding output signal, this is similarly time axis and this is the output axis. The output will be like that. So that means the output of the system does not depend on the time of the input axis. Okay, it is completely different. So this is called a time invariant system. But if we draw a system in that manner, that is there is a phase shift or time delay capital T. So that means the system will start after the t seconds like that. So this is the time axis and this is your input signal, that means x of t minus capital T. Okay, there is a phase shift. So in the corresponding output will be like that. The output, if the output will also follow the phase shift, that means there is the same phase shift capital T and the output will like that. That means this is the time axis and output will be y t minus capital T. That means in the second figure the output signal will exactly follow the input signal, that means exactly dependable on the time. As the input is started from the t phase shift of the origin, the output will exactly follow the same manner, it will start the t second later. So the first figure is called time invariant, whereas second figure is time varying, right? So this is the basically differences between time invariant system and time varying system. Okay, nothing else. So next part is number 3, linear system and non-linear system. So what is linear system? A system, it may be continuous time or it may be discrete time system, is said to be linear if it obeys the properties of superposition. This is the mainly important point. The linear system will follow the properties of superposition. Under this category, the first property is additivity. Okay, additivity, and the second property is homogeneity. So if a system follow these two properties of superposition, that means the additivity and homogeneity, then it will called as linear system. Otherwise, who disobeys these two property is called non-linear system. So what are the two properties of additivity and homogeneity? So first one, if we discuss about additivity, additivity means suppose there are two input signal. There are two input signal like x1t and x2t, and the corresponding output signal are y1t and y2t. So the additivity property states that if x1t plus x2t should correspond the output y1t plus y2t. So this is the property of the additivity. So this property must be followed when a system is said to be linear system. Okay. And what is the property of homogeneity? What is the property of homogeneity? Suppose the input signal is same, that is x1t and x2t, and the corresponding output will also same, that means y1t and y2t. So the homogeneity property says that or states that a1 x1t will correspond the output a1 y1t, okay, and a2 x2t should correspond the output a2 y2t, where a1 a2 are some constant, a1 a2 are some constants. So this is the property of homogeneity. So if we combine these two properties, that means when a system is said to be linear, That means it combines these two property of superposition. That means the combining properties of superposition, right? That means a1 x1 t plus plus a2 x2 t should correspond a1 y1 t plus a2 y2 t. So by combining additivity and homogeneity, we get this property of superposition. If a system follows this property, then it will said as linear system, right? Otherwise it is said as non-linear system. Okay, clear? Next is number 4. Number 4 is instantaneous system or static system and dynamic system. Instantaneous system and dynamic system. Okay, so an instantaneous system, it is also said as static system, is a system where the output of any specific time depends on the input, that time only. Okay. On the other hand, a dynamic system is one whose output depends on the past or future values of the input, right? Suppose basically a static system or instantaneous system has no memory, it contains no energy storage element. Okay, while a dynamic system has one or more energy storage element. Suppose we give the example, an electric circuit containing a passive element like resistor. It has some VI characteristics, that is V equal to Ri by Ohm's law, and so the system is static. But when a electrical system containing a capacitor, it has also a voltage current relationship. So in case of instantaneous system, we know that VIT is equal VT is equal to R of IT by the Ohm's law. Okay, but electrical system containing capacitor, then it has also a VI relationship. So the value will be Vt is equal to 1 by C integration It dt 0 to t. It has already known to us. So this system is called the dynamic system. This is the basic difference between instantaneous system and dynamic system, right? So the next one is number 5, causal system and non-causal system. Causal system and non-causal system. So what is that? A system is said to be causal if the output of the system depends only on the present time input or in the past time input, but it does not depend on the future time. Only depends on the present time and past time. That means present state, or suppose the present state is k, the past state will be k minus 1, k minus 2, like that. But it will not depend on the future state. That means k plus 1, k plus 2, it will not. So in this system is called the causal system. On the other hand, if the output of a system depends on the future time, that means the present state will be is k and the future state will be k plus 1, k plus 2, k plus t, like that. So it will be called non-causal system, right? So suppose x n is the input. Okay, suppose input is xn, the corresponding output is yn. So the moving average, average of the system is described by suppose so discrete time system, it it only denotes by a third bracket, because in my previous lecture I already told that the continuous time system or signal is denoted by a first bracket and discrete time system is denoted by a third bracket. Okay, so it will also follow the same manner. So if we discuss the moving average of the system, suppose yn, so it will be one third of xn. So this is the present state, and the past state will be x minus 1, x minus 2. So this is an example of causal system. Okay, and if we write an example of the non-causal system, suppose yn will be one third. This is the moving average. Okay, x of n plus 1, next xn or x n minus 1. Okay, so look, x n plus 1, that is the future step. The future step is dependent, so this is called non-causal system. Okay, very simple thing. Next, number 6. Number 6 is stable system and unstable system. Stable and unstable system. A system is said to be stable where the output of the system does not diverge as long as the input signal does not diverge. Okay, that means a boundary input system produces a boundary output. It does not diverge. Okay, so this system is also called, the stable system is also called BIBO system, B-I-B-O. That means boundary input, boundary output. Okay, this system is called stable system. Otherwise, on the other hand, the output, if the output will diverge from the input signal, it will call the unstable system. Nothing else. Pretty simple concept. Okay. Next is invertible system. Number 7, invertible system and non-invertible system. Invertible and non-invertible system. Okay, a system is referred to invertible system if there are two properties should be followed. Number one, distinct input lead to distinct output. Right? And number 2 property is the input can be recovered from the output. If these two property are follows, then a system is called invertible system. That means the input can be recovered and distinct input lead to corresponding distinct output. Otherwise, the system is not followed by a, if these two properties is not followed by a system, it will called as invertible system, right? So, if we draw a block diagram of invertible system, suppose this is the input signal xt, okay, it will go to a system because the system is an entity which can take the input system and produce the output. This is a basic definition of a system. I have already told this. And invertible means there is a inversion process that will take place. Invert system, and we get the input signal again. That means the input can be recovered from the output. Look, we give the input xt here, and at the output of the invert system we get the same input, that xt. Okay, so this is the basic categories of different types of system. Okay, next. So next thing is elements. Okay, next thing is elements. Under this category, the first one is active element and passive element. Okay, active and passive element. So what is active element? If a circuit has if a circuit element has the capability of enhancing the energy level of the signal passing through it, then it is called the active element. That means the example of active element is voltage source or current source or semiconductor. That means it enhances the energy level of the circuit element. Okay, the example of active element will be voltage source, current source. Whereas the passive element, that is the energy storage element. That means it simply allows the passing of circuit element with a constant without enhancing the energy level. Whereas active element will enhance the energy level, passive element simply allow the circuit element to flow through it but without enhancing the energy, that it can store the energy. It is called the passive element. The example of passive element are resistor, inductor and capacitor. So these are the passive element. So number two classifications are unilateral element and bilateral element. So what is unilateral element? The magnitude of current passing through an element is affected by the polarity of applied voltage. Then this element is called the unilateral element. That means the current magnitude is dependable with the polarity of applied voltage. So it is called the unilateral element. The example of unilateral element are diode, transistor, etc. Why diode is unilateral element? Suppose we all know that, so this is a representation of diode, this portion is anode, this portion is cathode. If the polarity of input voltage is like that, that means the anode is more positive than the cathode, then the diode acts as a forward bias diode. And if the polarity is reverse, that means cathode is more positive, that means cathode is more positive than anode, then the diode will act as a reverse bias. So the current flowing through the element is dependent with respect to the polarity of the applied voltage. So it is called unilateral element. And in case of bilateral element, the current magnitude remains unchanged. The current magnitude remains unchanged with the polarity of the applied voltage. So this is called the bilateral element. The example of bilateral element are resistor, inductor and capacitor. So this is called the bilateral element. Okay. Next, number 3. Number 3 will be lumped element and distributed element. So what is lumped element? Lumped element are those elements which physical size are very small compared to the wavelength of the input signal. They are called the lumped element. Okay, that means the physical size will be very small compared to the input signal propagating through it. So the example of lumped element will be same: resistor, inductor and capacitor. And distributed element means the physical size of the element is comparable with the input signal. So very common example of distributed element is transmission line. Very common example. It may be short transmission line, it may be medium transmission line, or it may be long transmission line. Look, here is a very interesting thing, that is resistor, inductor, capacitor are called passive element. Resistor, inductor, capacitor are called bilateral element, and resistor, inductor, capacitor are called lumped element. So this is the 3 major categories of elements. Okay. Next thing is, the next point is sources. Right. The next point is sources. So first of all, what is the energy sources? In electrical and electronic circuits, some components or some elements are used to supply the required level of energy to the operation of the circuit. So these components are mainly known as energy sources. Okay, these components are mainly known as energy sources, which are used to supply the required amount of energy to the operation. Okay, the broad classification of the energy sources are, we all know this is a very basic thing: voltage sources and current sources. Voltage source means the energy source is required to create a voltage difference, basically a potential difference between the two input terminals. Okay, so this is called the voltage source. And current source means it delivers the current through an element for the operation of the circuit. Okay, under this category, that means voltage source or current source may be further classified as independent voltage or current source, number 1, and number 2 is dependent voltage source or current source. So independent source means a voltage source or a current source is said to be independent, where the output voltage or output current does not depend on the input voltage or input current or any other part of the circuit element. That in that case, the voltage source or the current source is called the independent source. That means its output voltage and current does not depend on the any input part. Okay. Under this category, so first one is under independent source, the first one is constant voltage source or current source. The second category is time varying. The third category is ideal, and number 4th is practical. So these are the four major classification of independent voltage source or independent current source. Number one is constant voltage or constant current source. Number two is time varying voltage source or time varying current source. Number three is ideal voltage source or ideal current source. And number four is practical voltage source or practical current source. Okay. So at first, what is constant voltage source or constant current source? That means it is also called time invariant. Okay, that means the independent voltage source or independent current source whose output voltage or output current remains constant throughout the entire operation of the circuit. Remain constant. That means the example of constant source, that is batteries, cells, etc. So these are the example of constant voltage. That means the output is remains same. And what is time varying? Time varying means whose output voltage or output current are changeable with respect to time. So one more thing that is important, that the change in output voltage of the time variant independent voltage source or change in input voltage does not produce the changeable output voltage or changeable output current. It only changes with respect to time, not respect to the input voltage or input current. So this is called the time varying voltage source or time varying current source. Okay, the example is suppose alternator, or it will called as synchronous generator, AC generator. These are the example of time varying voltage sources. Okay, so next one is ideal voltage source or ideal current source. At first, suppose ideal voltage source what is ideal voltage source? A voltage source which has zero internal resistance is called the ideal voltage source. Practically it is not possible. That means whatever the supply voltage we give or we apply to the input, the same amount of voltage we get from the output. That means, so this is the input voltage and the I current is flowing, and so this is the VI and we get the same amount of output voltage. There is, because there is no voltage drop inside the internal resistance, because there is no internal resistance present. That means they are across the, if the internal resistance is present with the series of the supply voltage source, that means if the figure will be like that, there is an internal resistance present in series with the supply voltage R. So this is called the practical voltage source. That means the output voltage is always less than the input voltage, because there is a voltage drop across this internal series resistance. Okay, so if we plot the graph, suppose the graph will be like that for ideal voltage source. So this is current, this is the voltage axis. Suppose this is a constant, so this is the V input, this is the V output, is also same constant. Okay, so this is the simple graph of ideal voltage source. Whereas in case of practical voltage source, V output less than the V input always, because there is some amount of voltage drop across the series resistance. So ideal current source means, ideal current source Look, in case of ideal voltage source, there is a zero internal resistance. But in case of ideal current source, which has infinite internal resistance, because the resistance is always connected in series with the voltage source and in parallel with the current source, not series with the current source. So if suppose this is a current source supply Is, and this is the output terminal, so this is the load current. Okay, that means output current of an ideal current source is equal to the source current due to infinite internal resistance. Thus, an ideal current source always delivers the same current through its operation when a load connected through it. If we connect a load in this terminal, that means whatever current is given to the supply, the same amount of current is flowing through the load. Any change in load circuit does not affect the output current. If we increase the load or decrease the load, it will does not affect the output current. So, but again, ideal current source are practically not possible. So, if we plot the graph, this is the voltage axis, this is the current axis. In this case, we consider about the current source, that is plotted in the y-axis. So, this is the IS or IL. That means if we connected a load here, this is the load terminal, the supply current is same supply current is flowing to the load current, to the load. Okay, and in case of practical current source, practical current source is one which has a finite internal resistance connected parallel with the source current. Okay, that means the circuit will be like that. So this is the current source and here is the internal resistance connected parallel with the source current, and here is the load terminal. That means this is the supply current and this is the load current. Some internal resistance R is mentioned here. Okay, when there is any change in load voltage, the current delivered by the source is also changed. It is because the increase in load voltage forces to draw extra current from the source to flow to the load terminal, which that means extra current flowing to the load terminal means there is a decreased in output current. If the load voltage is changed or load voltage is increased, that means the extra current, the increased current, the extra part of the current is drawn from the supply current. That means the load current is decreased or reduced. So this is the concept of practical current source. The last one is dependent source. Dependent source means are those whose output voltage or output current is governed by a voltage or current, obviously input voltage or input current or any other part of the circuit element. That means output voltage or output current is dependable, it's changeable with respect to the input voltage and input current. So this is called the dependent sources. So dependent sources are generally represented using the diamond shape. Okay, so there are four major categories of dependent sources. The first one is dependent voltage source, and the second one is, it is also known as VDVS. The second one is current dependent voltage source, CDVS. Third one is voltage dependent current source, that means VDCS, and the last one is current dependent current source, it means CDCS. So these are the four major classification of dependent voltage sources. So these are the mainly these voltage source or these current source are referred to as controllable voltage source or controllable current source. They are used to sometimes they are used to represent in an amplifier circuit, their application. Okay. So if we draw the diagram of first one is voltage dependent voltage source, all the controllable or the dependent voltage source and current source are represented using a diamond shape. So so this is the figure of VDVS, that means voltage dependent voltage source. So it is represented by KVX, where K is some constant, nothing else, some constant or some portion of the supply voltage, K of Vx. Next one is the current dependent voltage source, that is represented KIX. Okay, current dependent voltage source. This is the representance K of Ix, some portion or some amount of current, that is K is some constant. Next one is voltage dependent current source, that means VDCS. So it is look like that. Current source, it is denoted by this arrow, the current flowing direction. So this is KVX, VDCS, that means voltage dependent current source. K is some constant, which portion of supply voltage is represented as a current. Okay, VDCS. Now last one is current dependent current source. So the diagram is like that. It is represented by K of Ix, that means the portion of current will be represented, that means CDCS. So these are the four classification of dependent sources, dependent voltage source or dependent current source, that are basically known as the controllable sources. Okay, so with this I am ending the today's lecture. These are the total concept of different types of system, different types of element and different types of sources. Okay, thank you.